rabies work was with her. But I am at Penn State now, and before I get started talking about the hub work over the past year, I really want to highlight that it's been a huge effort with lots of input from different groups and institutions, also in collaboration with the Midas Network. I'm sure that many of you are already members, but if you're not, perhaps consider joining. And then to put what we do in context, so we're really interested in these longer term projections. So these epi curves, everyone's familiar with, forecast usually on a bit of a shorter term in terms of maybe weeks ahead, but we look over 6 months and more recently up to a year cases, hospitalizations, and deaths for COVID-19. And at these longer time scales, it becomes especially important, the changing conditions. And so we consider different scenarios. So we can look at different ways that NPIs are changing, consider how vaccination campaign rollout may play out, as well as possibilities for the emergence of new strains when we don't know everything about them. So as an example, our 7th round, we were looking at vaccination and Delta transmissibility. So just showing the 9 models for the high transmissibility scenarios here. But as part of a hub, we're able to address different areas of uncertainty. So particularly here, as Delta was emerging, we didn't know what its transmissibility and interaction with previous immunity would look like, as well as how behavior and interventions change. But by having all of the models address the same scenario, we can then compare them and also combine them into an ensemble. So we use the linear opinion pool methods to do that. And then you get this kind of general sense of what the models are saying. So there was a lot of variability here in round 7 at the beginning of the Delta wave. We've almost completed 10 rounds since the beginning of or end of December 2020. I'll focus on round 9 today, where we looked at scenarios with childhood vaccination. We had a training round for waning immunity. As you can imagine, incorporating that in models is not an easy feat. So that's an ongoing effort. Here is an overview of what those projections have looked like. Sorry if the bottom has been cut off. So each different color is a different round. You can see the solid lines in the middle are the ensemble projections for each of the different 4 scenarios in each of the rounds. And you can see that for different rounds, we track more or less with the observations. But given that we define the scenarios before these projections occur, we qualitatively think that we do pretty well in capturing those trends. But validation, particularly in the scenario setting, is really difficult and something we're always working on. So in round 9, I mentioned it was about childhood vaccination. Projections started in September, mid-September. So this was before the recommendation that occurred in earlier November. And we looked at the sort of a yes or no whether childhood vaccination started in early November, and uptake rates were specified to match the 12 to 7-year-old uptake in each state. So to capture hesitancy differences between states, we looked at 2 different transmissibilities. So one assuming Delta stayed predominant, and one where we had a variant emerge in mid-November that was 1.5 times as transmissible as Delta. So not with immune escape, but there was sort of a stress test to see what could happen if things change. Teams used their own vaccine efficacy assumptions, since we didn't have, or for at least for children, since we didn't have information on what that would look like at the time. So here are the results, the ensembles for each of the scenarios. And these are the 9 teams that contributed. You can see one of the biggest things is the divergence between the variant and no variant scenarios. So in blue and gray, the variant scenarios, the sort of the major difference between the different scenarios is their increase in the beginning of 2022. The dashed line is when we specified that vaccination would start, and the models used only data prior to when the shaded region starts. So those are the 95% projection intervals. So it looks like there are relatively small changes between when you have childhood vaccination or not, but they add up, as I'll show in a second. So one of our validation avenues that we've been looking at is looking at the ensemble state level results and seeing how our observations align with projections. So these are just through October 30th, which was before we assumed that vaccination would start. Then along with the 1-to-1 line in red, it's not aligning quite as well when you look at more data, but at least the relationship between different states is staying pretty consistent. Okay, so we did a meta-analysis to look at or compare the variant to vaccination to non-childhood vaccination scenarios. And we see a larger effect on the right when you have the introduction of the variant, but still a reduction without the emergence of a new variant. So this is looking at the period after we assumed that childhood vaccination would start on November 1st through the end of the projections, March 12th, 2022. And we see about 7% fewer cumulative cases over that time frame in the random effects model that aggregated over the different team results, which turns out to be around 430,000 cases. And then that contrasts with the 10% fewer cumulative cases if you have the emergence of a new variant, which is about double the cases. So these relatively small looking incidence changes do add up over time. And we saw similar patterns for hospitalizations and deaths. So to compare, we see different amounts of uncertainty in different points of the pandemic. So around 7, I showed at the beginning, there was really a high level of variability across the models in the emergence phase of Delta. Versus in round 9, on the declining phase, we have a little bit more consistency between the models, still to projecting a later peak. And this is the national ensemble, which aggregates all of the state level projections. Okay, so just to summarize, the importance of the hub structure with the shared scenarios. We also have frequent group discussions that allow us to compare the models, but also get the models on the same page. So we're able to actually see what differences are that result from the different scenarios versus just differences in the models. We qualitatively capture COVID-19 dynamics. Round 9 was a particularly good round in terms of matching up with what's been projected over the following 3 months. We are able to look at different levels of transmission with new variants, NPI effects, seasonality through the different approaches of the models. And they also use different calibration approaches as well as different model structures. So for example, the age groups considered vary between models as well as the spatial resolution, but everyone submits state level projections and a national level projection. And then waning immunity is something we're working on, and groups are accounting for that differently. But we realize that that's something we, at this point, need to have in the models that are submitting projections. So we'll be making sure that that's included moving forward. As I mentioned, we're always working on validating these scenarios our projections of the scenarios. It's pretty difficult because we don't ever see any of the scenarios play out exactly in real life, because we're making these assumptions about what will happen. So we're continuing to work on that, and then also considering how our ensemble aggregation methodology influences what we see in the ensemble. So we do talk with the CDC a lot, and they help us choose which scenarios will be most helpful to them, as well as inform the government leadership. These results were used in the ACIP meetings leading up to that recommendation. We have a lot of interest from different public health stakeholders, as well as the media. So we share a report with this public health stakeholders, and then also have a website where the projections are publicly available. And it's nice to see after each round, there's usually a pretty good uptick in site visitation. So I just want to thank everyone again, all of the people involved in the work. It's certainly a huge effort involving many individuals. That's our website there in the bottom right. And I guess I'll pause now. So I kind of flew through that. So I'll pause for questions, and I'm hoping we might have some time to talk about our Omicron scenario development, but would like to pause here and see if there are questions.
First of all, thank you. No, I was gonna.
I went really fast. I'm sorry.
No, that's great. No, thank you for the presentation, and really for like this service that you're providing for science and public health. It's really just amazing what your group is doing, and it's one of the most, I think, game-changing things that's happened in science throughout the pandemic is this sort of collaborative ensembling, or whatever you would call it, approach. It's really makes I don't know. I think it helps the decision makers to trust the science more when they can kind of look at these things. So I think it's amazing.
We're working on it. It's really the modeling groups, though. Their time. It's just amazing how everyone's.
Yeah. So I guess one of my questions is, I mean, we've been involved in, well, we were involved in Kat Shea's original scenario thing. And then even before COVID, we were involved in some work with the CDC, and we're now trying to help out with the Omicron scenario modeling. But, one piece that we were doing prior to the pandemic that we just really haven't had much time to do is sort of this round of comparison and model validation, right? Like everyone submits all these different forecasts, and they really could just boil down to, different expertise, different assumptions, all of which are plausible, and they help us kind of reasonably assess the range of uncertainty. But it could also be, and we found this when we had a little more time to do it, that some of the models had bugs, or we screwed up with our assumptions, or we miscommunicated, we misunderstood how the CDC was giving us parameters or whatever. And I'm wondering, how much of the variation do you think is due to kind of authentic variation, the kind of variation we want in our proposal, in our projections, and how much, if we had a little more time, would kind of go away because we realized, we were actually modeling a different thing or something like that?
Yeah, so I definitely think there's some of both. The intermediate discussions are really helpful. So similar to the multi-model outbreak decision support effort that preceded this, we sort of have like a within round process where we really make sure that the teams are interpreting the different pieces of the scenarios in the same way. So I think we've avoided some potential, like divergences that we didn't actually want because of misinterpretation of parameters, or different interpretations that we didn't actually want or weren't trying to characterize. So that helps us pare it down to more the specific things we do want, like different people make different assumptions about NPIs, about vaccination, the things that we don't know about, and each team definitely, brings their own expertise on that. I will also say, I think that through the process of having 10 rounds, the teams that there's a core set of teams that have, been with us the whole time, and you can see like it does become easier. And as far as like submitting the weekly projections and waning immunity, I think is a good example of like, it's been really hard to capture, and by having these multiple rounds with some of the same teams, we're sort of hopefully making progress towards having uncertainty that we want to show in the projections, as opposed to not.
Yeah, thank you.
Peggy, one question I've had since, I think since you released the results from round 7, there was one model in there that seemed to actually like fit super well with the Delta surge. Yeah. And since that point in time, I've always wondered, do you ever look back and try and see like, well, what was it about this specific model that really captured the trend?
Yeah, so it's interesting
for that one specifically, but just like in general, I guess.
Yes, so that model, I know exactly which one you're talking about. It looks like it's at the national level, just tracking right on with the projections. But if you, here I can just share. So the purple line here on the left, pretty remarkable match, it appears, there at the national level. But if you look at the state level, it's not that spot on, like it differs between states. So we don't think necessarily that there was like a particular mechanism that model was just really capturing better than the other models. But yeah, I agree. It's pretty amazing how it happened to line up there that way at the national level.
Okay, that makes sense. Because like, I mean, if you have enough models, just through chance, like one of them is probably going to get the dynamics right at the national level or at some different levels. And I was just curious.
It is a good and interesting point. I think teams that really specialize or think about the variants and are incorporating variant emergence data, that has been a little bit of a divider, or you can group models into sort of like, some are like really concerned about, they were using Helix when that was available for Alpha and Delta to inform their projection, the growth rates at the beginning. So that certainly is one thing I think capturing the variant emergence is important, but difficult.
I have a quick question. Could we just jump to the like distinction between forecast range and scenario range?
Sure. Yep.
Great. So we can't validate, you brought up a great point, which is we can't validate projections, but could we validate forecasts and then sort of like update projections conditional on forecast evaluation? Do you see any link between those two, or are they just like two totally separate objectives? So like information from forecasting doesn't give you any information about projections.
They're definitely linked. And I think looking at the short-term projections is a bit easier and has been one of the ways we've been moving towards trying to validate a bit more. So at the beginning, right, the models use all of the data available up to the point where they have to submit the projections. And then there's often like one scenario that's sort of most in line. So like in this case, in round 9, no child vaccination, no variant. We could use that particular scenario and look at that, compare those projections to the observations, which helps a little bit, and then it just becomes harder over time. So it is, yeah, but I think the longer, that longer time scale is really difficult. We've also been looking at cumulative, like, so how are the models and the ensembles doing with cumulative outcomes, cases, hospitalizations, and deaths over timeframes. So at the end of the end, some of the work that we want to do is like comparing past rounds and looking at how the models are doing sort of on their own. And I'm not sure if that addresses your question, but there's an interesting interplay, I think, with the timescales and the scenarios. And you could have short-term projections. It's not discrete, sort of in the sense of at some time it becomes a projection versus a forecast.
That makes a lot of sense. So you sort of have to validate two things, like both the actual counterfactual scenario that came true, and then also the model performance conditional on that scenario being true.
Exactly. That's a really good point to highlight, is that
yeah, that's interesting.
So yeah, not only is it how well are the models capturing the dynamics of what's going on epidemiologically with the virus, behavior, et cetera, but when we specify those scenarios, how well does that actually match up with what ends up happening?
Rebecca, I can't remember if you said this, but do any of the models incorporate behavioral feedback? Like, do they?
Another great question. So we do have like some behavior in some of the models used, so definitely like mobility data. And I know that's, I think, not your question. The extending it to a feedback response in terms of we're seeing these large jumps in hospitalizations and deaths, people are going to start staying inside. We have mostly steered away from incorporating that to start. And I think eventually we want to do scenarios that incorporate that. But for these initial phases where we're getting things up and running, we just want to compare like between the scenarios and having that extra layer of uncertainty between the modeling groups. We thought that it would just be best to focus on the scenario comparisons without it at first.
Yeah, I mean, that seems like something when you get to the point where maybe you wouldn't specify it across models, but you'd let the scientists incorporate their, best hypotheses for what kind of feedback there is. And you can have them, you can have them run among their scenarios, assume no behavioral feedback, just so you make sure things are kind of look similar when you don't have that in there. But that's something where I think, especially if you have social scientists involved in some of these teams, where it would be great to get, different scientific expertise baked into the models.
Yeah, I definitely agree. And I think had Omicron not come along, it's kind of like we're, always trying to catch up with what's going on, and everyone wants to get to that point of having a behavioral feedback. But we just haven't gotten there yet. And I totally agree. It'd be really interesting and important.
Yeah. One other question, then I definitely want to give you some time to talk about Omicron, but I'm curious, like, how this is structured. Like, is the CDC funding this, and then the different groups are either doing this pro bono, or some of them are getting funding from the CDC? Like, what's the, and I know this has been evolving since prior to the pandemic, but what's the current structure of the effort?
The current structure is complicated and not super transparent. So some of the groups are getting funding from the CDC. I think we're moving towards a direction where there might be a little bit more of funding for like this specific effort. So I'm currently funded off a rapid, like CCNSF rapid for this. So like there is funding for me and another postdoc. but it's not a like cohesive like funding, like everyone gets money. But there are definitely plans for moving towards having some aspect of funding. But there's certainly interest in funding the work. And I also think hopefully we'll be able to integrate, maybe integrate isn't the best word, but with the new center, getting involved with them. And, you know, as that develops, sort of creating new pathways for how we can have the work well in parallel.
Yeah. I mean, it's been pretty amazing throughout the pandemic how so many modeling groups have like figured out ways, scrape the resources together to do modeling at the request of the CDC or whatever, even though the CDC maybe doesn't have the mechanism to directly fund that research. You know, there's been a lot of
I would say it's mostly
like
pro bono, like, and definitely the
Yeah.
earlier rounds, like
Yeah.
all pro bono, except maybe for like me and another rapid. Yeah.
That's great. I'd love to hear, your thoughts on Omicron.
Okay, so they're very preliminary and in development, and I am kind of hoping to also get feedback from you guys. So I'll just share where we are in terms of specifying our different axes of uncertainty. We saw in the beginning of the meeting today that area of uncertainty where you can't identify differences between, or it's very difficult, at least at this stage, to identify differences between immune escape and transmissibility, how that comes together to form the effective reproduction number that we can observe. So our thought was to collapse that into one axis where we have a different level of each, but they come out to have the same effective growth rate. So as you can see, we're still settling on what our intrinsic reproduction numbers will be that we'll look at and what immune escape will look like. And we might not do low transmissibility. So these would be relative to Delta. We might have like same transmissibility to Delta still, or like 2 levels of higher. So that's the vertical axis, or the, let's say, rows. And then, but we really wanted to incorporate uncertainty and severity. So we have sort of an optimistic version of severity where there's some reduction for Omicron relative to Delta. And then among previously vaccinated or infected individuals, we have these 85% hospitalization risk reduction and a 95% or vaccine efficacy for death or past immune efficacy, I guess. And then lower values, so 70% and 80% right now in the pessimistic severity case. So, and then there we have no change in severity from Delta to Omicron. So yeah, as I mentioned, super preliminary, and we're planning on updating these throughout the week as information comes in. Yeah, so I'm really interested in your thoughts overall on like if this makes sense, or if just anything really.
So the CDC specified some scenarios last week, right, that we've already put into our models. These look a little bit different than those, right? Are they different based on our evolving understanding of Omicron?
That's a good question. Yeah, they're, I think, different mostly for that reason. But yeah, I do know the those scenarios that you're referring to. And then, yeah, we're tweaking values since then. But we'll definitely be in touch with, so we're going to be in touch with, I think his name is Jason from Asper, to take a look at these and see, based on some of his preliminary work, whether these seem like they'll be of interest, in terms of, we want to have some distinction between the scenarios, so we see whether there's a difference. Obviously there will be a difference if it's more severe or not, but
Yeah.
so we can be like, we don't want the scenarios to all come out having the same projections.
Yeah. And I'm not sure I followed the X's at the top. Are you saying you're going to leave it to the modelers to divvy that up, or you're just still fleshing that out yourself?
We're still fleshing it out. Yeah, I think it's really important that we specify it, because if we just let the modelers pick what they want, I personally was really a little bit hesitant about combining that into a single axis, just because it's going to make such a huge difference in terms of natural immunity and vaccine immunity. Like, they really could be their own, but we just decided to collapse, but we'll definitely specify what those are so we can interpret.
Yeah. So I'm curious, like, and maybe this is obvious to other people, but like, if there's some equation maybe you have in your mind where intrinsic R naught is a function of intrinsic R naught and a function of immunostate gives you RT, but in that equation has to be the distribution of vaccination and past infections, right? And so if you really are trying to hold that constant, you have to be making some assumption about what that immunological landscape looks like. So I'm curious how you guys are approaching that.
Yeah, perhaps that's why it's partially still unspecified, because it is going to be really complicated. And the modeling teams do all calibrate their own, distribution of immunity across the US for the different states.
I mean, one way you could do it is you could specify, like, let's say, give them an intrinsic R naught, say we want everyone's intrinsic R naught to be like 2 or whatever. And then we want you in your model to calibrate immunoscape so that you end up with an effective R naught at 3.5 or whatever. So that, and if that's what you want to hold constant across the models but that's tricky.
Yeah. Oh, yeah, it's really tricky.
Yeah.
It's so hard because, for all of the reasons, right? But particularly, I think state level differences between vaccination levels and how that's going to play out with Omicron. And, immunoscape is going to look so different potentially in vaccinated individuals versus individuals with natural induced immunity.
And I mean, and if you do end up specifying the intrinsic R naught and the immunoscape both, then you might just ask the modeling groups to tell you what the resulting effective RT is, so that you can understand that kind of range of what that produces across models, or even, in a given model, what does that produce across states, right?
Interesting. Yeah.
One thing that will be, I think, very complicated in the US is the fact that we still have Delta at really high levels. And if Omicron comes now, then it's not just immunoscape of Omicron versus Delta that is important. It will also be important what's the immunoscape of Delta versus Omicron. Because I think we will still have both infections going on at the same time.
Yep, I totally agree that the whole invasion timing spatially of Omicron is going to have a huge effect, teasing apart. And so that will be different probably across the models. And those values will be different. Yeah, I agree. That's going to be another complicating factor for sure.
Looks like Holly, you have a question?
Yeah, I was interested in your comments about natural immunity versus vaccine immunity. And do you have like some ratio or number or sense that you put into your models about this?
So there are a couple different things going on. So all of the models have their own structure with different age groups, or they're not all different with respect to age groups necessarily, but so then they calibrate their models to past COVID-19 data at the state level, and also use information on vaccination rates, vaccine uptake in the different age groups, to calibrate their own immune landscape across the US. And that will be different for vaccine-induced immunity versus natural infection immunity.
So my question is, in what way is it different? Is natural immunity better? Is vaccine immunity?
Oh, okay. We don't know, but I think we're hoping to get more information on that. And so as I think Casey was going through some different studies earlier, there are like some preliminary results from neutralization assays, and but I certainly don't have that answer.
It's maybe Spencer, you remember, I know Carl Pearson's work looks at reinfection. Is he able to, in that study, compare it to breakthrough infection for vaccines?
So, I mean, basically, we don't know. Is that a good answer?
Yes, that's the best answer. And it's true. So we're all of this work, and so like specifying an RT of say 3.5 is based on what we're seeing or have seen in South Africa, but their immune landscape with respect to which variants people have been infected with and vaccination rates is so different from ours. So there is really a huge uncertainty there as well.
Thanks, Rebecca.
I know we're getting close to 11:30. I had like just some other assumptions about booster coverage. So we want people to incorporate boosters. We're asking, this is the first round that we're going to require waning immunity for inclusion, which is a huge ask, but I think something we can't we have to include it now. And then continuing to incorporate childhood vaccination. We're not going to do updated vaccines in terms of ones developed specifically for Omicron. And we're leaving initial prevalence of Omicron versus Delta to the teams since we don't have, unfortunately, a lot of data on that yet.
I guess one last question, like, do you have a sense of what the most sort of actionable, like this policy questions are now? Like what might happen based on what the scenarios tell us as far as decisions or guidance CDC would give to decision makers?
Great question. So I think here with these scenarios, so we don't have a specific decision axis, which sometimes we do, like, higher, lower NPIs, higher, lower vaccination rollout. One thing I think that's really of interest is like, will boosters be enough? So just seeing from the modeling results with vaccination as teams specify how bad are the projections, like, do we need NPI use to change and behavioral changes?
Okay. And one last question. This is for anyone, including you. You know, as everybody sort of in the back of the mind is, you know, are we going from pandemic to endemic? Has any quantitative stake on that? Like endemic is the point when the randomly infected person has at least a 50% chance of either it being a reinfection or a breakthrough infection or something like that. Is anybody putting a stake in that? And is that something you're looking at in these projections?